Okay, so here's another opportunity for us to kind of use our table here to answer some questions about, in this case, we want to know molarity, mole fraction, mass percent, parts per million, given the molality of KCl. So we're given the density, so that's easy to write down right here. That's the density down in this area. We're given the molar mass of our solute and the molar mass of our solvent. And molality. What does molality mean?
Moles of solute per... I gotta look at my notes just a second. Moles of solute per kilogram of solvent.
Okay, very good. So from the molality, we know moles of solute, kilograms of solvent. Okay, so 1 mole for every kilogram. Now, why did I put down 1,000?
Oh, because that's in grams, and it's 1 kilogram of water, which was 1,000 grams.
Okay, very good. Now, from these, what can I do?
Well, you can identify the mass of your solute.
That's right. I have 1 mole. This is the grams per mole. I know the mass of my solute.
And you can do the mass of your, or the moles of your water.
Okay, so this down here will just be my mass divided by my 18, right?
Yeah.
Okay, so if that wasn't clear, let me redo this for you manually here. So we got 1,000 grams of water, and we were wondering how many moles of water that is, right? For every 18 grams, I know that there's 1 mole of water, 18 grams of water. So that divided by my 18 is where I got that 55.51. All right, what else can I do?
Mass of solution, you can just add that up.
That's right. So 1,074.55, that can be my mass of solution.
Moles of solution too.
That's right. I can add up the moles of solution because it's just the sum of these two. Now what about my solution volume?
Solution volume. You got the solution mass as solution. I'm not sure.
Well, you were close. We have the solution mass. What does this information tell us down here?
The density?
Yeah. So if this is solution mass, can I get my solution volume from the density?
Probably. I'm not seeing it though.
Okay. So I'm after solution volume. I would like to maybe know how many milliliters of solution. Is that okay?
Okay.
And I'm given, or I have solution mass, 1,074.55 grams of solution. How can I use the density?
Oh, yeah, okay. So 0.98 grams for every milliliter.
0.98 grams for every 1 milliliter. Very good. So that divided by my 0.98 grams, and that'll give me my milliliters of solution. And then I want to convert that into liters maybe. So 1,000 or 1.096 liters or 1,096 milliliters of solution.
Why do you have some numbers small like that?
Okay, that's a good question. So, in this problem here, how many significant digits are we dealing with?
2.
That's right, we're dealing with 2 significant digits. And so the answer in the end is going to have 2 significant digits. But we don't always want to just throw away our significant digits between each calculation. And so we include them, but we keep them written in such a way that we remind ourselves that we're only going to have 2 significant digits in this answer. All right, and that subscript way of writing those extra significant digits is to remind ourselves that those digits aren't significant, but that's all right. We can hold on to them until the very end of our calculation. So from the information below in the table that we've generated from this information, can we identify the molarity?
Yeah, let's see. It's moles of solute. That would be 1 divided by liters of solution. That would be, where's liters of solution?
That's this stuff, right?
Oh, yeah, okay, 1.096. So 1 divided by 1.096.
Very good. So my molarity is 0.91 molar. Good. How about the mole fraction?
Oh, that was easy. You just take, well, okay, please. Moles total is 56.51, right?
That's right. Moles of solution is the sum of the moles of solvent plus moles of solute.
Okay, then 1 divided by 56.51.
Very good. 1 divided by 56.51. That should be 0.18 moles of solute per moles total. So that's our mole fraction. How about our mass percent?
That's grams of solute, 74.55, divided by grams of solution, 1,074.55.
Very good. 1,074.55. Whoops, I forgot to put in a divided by sign.
Oh, yeah, and then times 100.
That's right, times 100, so 6.9%. And parts per million?
Let's see, that was, let me look at my notes here, what we did last time. Part per million, you did the 4, carry the 6. Okay, so milligrams of solute, which is 74550.
Okay, milligrams of solute, so this times 1,000, 74550.
Divided by liters of solution, which is 1096.
Okay.
Oh, no, that's not right.
Why, what's wrong?
It's not 1096, it's 1.096.
Oh yeah, we're dividing it by liters, that's right. So let me go up here and fix this, make this 0.096. Very good.
Okay, yeah, so 68,000 or 6.8 times 10 to the 4th.
Very good. All right, excellent job. Here's another one now. This time we're given mole fraction. Mole fraction. Can we figure out all the rest of these from mole fraction and the density it's provided? That's nice.
Mole fraction, so I just know that that would be like 0.066 down there.
Right here?
Yeah.
Okay. So 0.066 is the KCl.
Oh, yeah, so it's over there.
But the 1 is the total moles. Is that okay?
Okay, yeah, I get that.
So then what can we do from there?
Well, I know that moles of solute plus moles of solvent equals 1 in this case, so I can just subtract 1, 0.06 from 1, so that's 0.04.
Oh, that's right. You could do that 0.94, right?
Oh, right, okay.
So 0.094 here, they did this first. Do you know where they got this?
Oh, that's the mass, so they must have just taken the moles times 74.55.
Very good. And then we could do the mass of, so let's just double check with the folks at home. We got this 0.94 from where?
Well, the moles of solute plus the moles of solvent equals moles of solution. So if we got 1 for moles of solution. Now, how do we get that 1 again?
Well, we're told that the mole fraction is 0.06. So that means 0.06 moles of solute for every 1 mole of solution. So we put moles of solution here, or moles total. I guess we don't really call it moles total or solution, but it is the same thing as moles total or solution. Okay, so 0.06 plus the 0.94 equals our 1. So how about here? How do we get our mass of that?
0.94 times 18.
Very good. And here?
That's just the sum of those two masses, right?
Very good. The sum of 14 and 16 here. How about the solution volume?
Well, we took the grams of solution last time and then the density, right?
That's right. So if I want solution volume, which is, let's say, milliliters of solution, then I can start with my 21.4 grams of solution, and then see that there's 0.87 grams for every 1 milliliter. So the 21.4 divided by the 0.87 is going to give us our volume of solution.
Why is that so small? Only 245.9 grams.
Well, Did I do that right? 21. Oh, I divided it by 0.087. So that was divided by 0.87 would be 24.6. In the beginning, we just identified the mole fraction, or we were given the mole fraction, and from that we generated all of our other parameters. The resulting volume here is much lower than we dealt with previously, but that doesn't matter. It's saying within these 24 milliliters of solution, these are the different amounts of the different components. So the ratios will still work out the same.
Okay, yeah, I got it.
All right, so how do we get the molarity?
That's moles of solute, 0.06, divided by liters of solution, which is 0.024.
Very good. So 0.06 moles per liter, 0.024. That should be my molarity. How about molality?
That's moles of solute, 0.06, divided by kilograms of solution, which is, no, kilograms of solvent.
Very good. Moles of solute, kilograms of solvent. So this divided by 1,000, 0.01693. So 0.06 divided by 0.01693 should give me my molality.
Okay, and then mass percent, that is grams of solute for every gram of solution times 100.
Very good. So folks at home, try to find the mass percent given the material that we have here. Okay. Should be mass of solute 4.473 divided by mass total 21.403. All right. And then times 100, times 121% mass solution.
Okay, good.
All right, and the last one, parts per million.
Milligrams, or 4,473 of solute, divided by liters of solution, right?
That's right, liters of solution, which is, in this case, 0.0246 liters.
Okay, so
folks at home, try to do that in your calculator. Try to get the right answer. I will work on it as well. Okay, so we got milligrams of solute, 4.473 times 1,000, divided by liters of solution, 0.0246. So we got 181 parts per million, or 1.8 times 10 to the 5th parts per million. Not 181, 181,829 parts per million. Okay. So, very good. Here's one now, and I'd like you guys to try to, from start to beginning, given the mass percent of 1.05% KCl, I'd like you to try to identify what you think that means. Again, what do you think, Fred?
Well, it's 1.05 grams of solute for every 100 grams of solution.
Very good. So I can put in here 100 grams of solution and my 1.05 grams of KCl, right? Know where that goes. From that, you can get moles of KCl. You can get mass of solvent by subtracting total solvent mass from solute mass, right? We can get moles of solvent, and we can get total moles by summing those two moles together. And then we can get the solution volume from the solution mass and the solution density. All right, hopefully that made sense. If you have another way to think about it, go ahead and try to fill in this chart all by yourself and then answer the questions in terms of molarity, molality, mole fraction, and parts per million. Okay, good chance to push pause. Okay, hopefully you got it. We're going to reveal the answers here. If you didn't get those, maybe you need to go back through the different previous slides, previous slides, and figure out how we got these answers. Okay, good job. Did you get it, Fred?
Yeah, I got it.